Welcome to the live stream for RStats Data Science. I'm your host, and today is going to be a little different because I'm going to be working. I discovered that I have to set up a new database type for my data because I've been using a SQLite database, but yesterday when we were so successful in importing a lot of data, I realized that the SQLite database is not going to scale to the size of data that I'm going to need. And so I spent today reading up on relational databases and best practices and storage. And what I kind of landed on is that I'm going to need to build a database that I can access locally, that's backed up, that is not well, it's going to need to be on a large hard disk. So, my computer here has a SSD on the C drive, and that's the OS drive, and it's relatively small, about 80 gigs free now. And I'm expecting probably to host somewhere between 100 and 150 gigs of data total in my database eventually. And the other thing I'd like to be able to do at some point is build that database, rebuild that database on a cloud machine, or make it at least accessible from another machine that has more computing resources than my local machine. So kind of hit on the idea that the best way to go with that is to use Docker to containerize the database system and use the containerized database running a small lightweight Linux image that is running PostGres as the database engine itself, because that's free and open source relational database. It's a little overkill for where I am now, but it's probably not overkill for where I'd like to go with this project eventually. And so because of that, I think it's worth starting the process with. I've never worked with Docker, and I've never worked with Postgres at all, so I'm a complete newbie here. And I did manage to get a kludgy setup of Docker working this morning, and now I'm just trying to figure out how to read and write from a Docker image or from a database stored on a Docker machine on my local machine. You'll see here I'm throwing on error already. I'm not getting the right encoding in my data before I pass it into the Postgres database. So this is going to be a short stream. And because I got started a little late today, and I spent a lot of the day reading, and that doesn't really make for an exciting stream. But I'm going to show you a few things. The first is, if you are running Windows 7 like I am, you have to install something called the Docker Toolbox. And the Docker Toolbox basically is a virtual machine running on Oracle Virtualbox. And you can see that I have a different virtual machine that I actually use for Linux testing, and it's right here. It's not running right now, but I have this one here, this Docker one, and it is running. And when you install the Docker Toolbox in Windows, it sets up this machine. I had a heck of a time figuring out that where I'm going to store this machine. And I had to drag it over. I need to have it on this disk data, and I do have it there now. And I put it in this folder Docker, and luckily I think that this folder is where the data that I'm putting into the database is getting stored now, which is good. It's not on the SSD. So I installed Docker there. I ran the Docker quick start. That set up this basic virtual machine. And then when you want to do something in Docker, you have to run the Docker terminal. And I'm running it, since I already have Git installed for Windows, I'm running the Docker terminal in my Git bash. This kind of kludge is kind of necessary when you're doing development on Windows. And so I basically there's basically a little setup script that you can run. It lists what's running. I have this my Docker machine running locally, and inside of that it's running one Docker container. That's what it's called, which I call CivaDB. Civalytics is the name of what I'm trying to build, and so I just shortened it to CivaDB. And it's built on this PostGres image by this user of Docker, M. Dillon, and I opted for the PostGIS flavor of Postgres because I do think I'm gonna get into geospatial querying eventually. So I went ahead and built this PostGIS machine, and then I wanted to connect to it in R, so I had to install the R Postgres SQL package, and that gives me this set of functions, and I have this function PostgresCon, which basically builds the connection string just like it would to a SQLite database, but with some additional parameters. The real trick that I learned this afternoon that took me a while to figure out is that you really need to forward the ports on the container to the virtual machine in Oracle Virtualbox that's hosting it. So this virtual machine has an IP address that only within my network can be seen. So the computer I'm streaming to from is within my network. But the container has a different IP address that I can't see from outside of the this virtual machine here. So there's like a Windows computer, Linux computer, and then a container. And you have to figure out how to pass the ports from the container up to the Linux computer so that your Windows computer can call into it. And it's actually a simple flag that you pass, the -p, and you pass the -p flag, and you list the port that you want to map from the container to the port that you want to map it to onto the virtual machine. So once I got that set up, it was actually pretty easy to figure out, okay, now all I have to do is type in the IP address that this machine is assigned, this Linux VM, and the port, and then that will pass through to the container which actually hosts the database. And then all I have to do is have a Postgres driver in R, and then I can access a username and a password and a database name, which I had all set up with the Docker image. Then I can pass queries and stuff to it just like I normally would. That part is going pretty well. The problem is that Postgres is not the same as SQLite. It's a little more heavy, and it has more features, and it cares more about things like encoding, and it has more data types. And ideally, the R PostgreSQL driver should abstract that away, but I'm finding already that it's not. So just loading my simplest data, which is this clearance data that I've been analyzing till now, easily loaded into a SQLite database, but loading it into Postgres, I keep running into encoding errors. Also run into the issue that Postgres expects lowercase instead of uppercase names for things. So I found on the great WinVector blog, I actually found this great little function. Is it DB safe names? And DB safe names actually allows you to take out the things that cause problems in names and make your database names clean. So yeah, if we look at this, for example, now these names are all valid names in Postgres. Before they were all in capital letters, and can't have a period, for example, but you can have underscores. So just as a way to make sure that these are safe. But still, despite doing that, when I try to write to Postgres, this agency year, this ID codes vector line 83425 is an error. So at least it tells me that. What's in line 83425? A bunch of NAs. I don't know that these are the first NAs, but it is a problem. So I think I have to maybe write a function to force the encoding when there's missing values. I have to Google around a bit more, but it's not super interesting for us to think about today. So what's happening now is on my computer, drag the task manager over here for you. My computer, I actually have my R session open, but there's also a bunch of other stuff open. But there's this Virtualbox headless process which is running. And that's basically where my Docker virtual machine is running. And within it, the container for the database is running. The upshot of this, I think, is once I build out the database, I can take a snapshot of this virtual machine. I can move it to another computer, and it should have all the data with it and be able to be accessed in the same way with the same username and password, which is making my code more portable. Didn't really want to have to scale up this much this fast, but you know, this should it'll make writing slower, so I'll have to do my ETL scripts, overnight or something, but it should make reading the data faster, and there is even the ability to use dplyr directly against a PostGres database, so I should be able to pull data down in a more seamless fashion, and I think in the long run that will wind up being better. So I just thought it would be interesting to show you that I have to run Docker, I run this Docker quick start terminal, and I'll just show you that actually. Just Docker quick start terminal. It fires up. There's Docker. I type in Docker PS, and I can see that my container has been running for about an hour. If I want to stop it, I just say Docker stop. Oh, I gotta tell it which one. Give it the alias civdb, so it's gonna try to stop it. It's probably not happy because I have an open connection to it in R. And then if I start it, there it is. It's been up for 1 second. So now that it's up and running, I can try to connect to it. Again, I'm going to use this function which hides my username and password and all that stuff. Not that it matters because it's only accessible within my local D, but now I can do this, db list tables con, and see that I have agency year, clearance month, I have all this other stuff, which is, these are lookup tables that PostGIS comes with, so you can use these to run routines to identify GIS features. I'm not going to use that kind of stuff just yet, but eventually I hope to. So the one thing I want to do is drop table agency con, because when I don't have when they're in all caps, then they have to be surrounded in quotes, and I don't want to be messing with that. So now I can say fields con clearance month There's all the fields, just like I would expect. Fetch, send, select top 100 from agency. I guess top is not. Top 10 values in PostGres. I guess you just limit. Nothing is written in agency year because of the error completing the writing. So that's what I was checking. So that's basically where I'm at right now. I have a simple Docker container running. It doesn't have a lot of memory and it doesn't have a lot of data stored in it because I haven't figured out encoding yet. Tomorrow I hope to have the encoding stuff figured out and should be able to have built the database by then and be querying against it. But for now, I have to learn a little bit more about the file encoding. I know that the files that I'm bringing in are encoded in ASCII, and then I'm going to have to figure out how to get that into the encoding that the database that I'm setting up expects. So not as much progress as I hoped, but probably tomorrow we can actually get into some nitty-gritty of analysis. So short little stream today, but hopefully tomorrow we'll have more to talk about. So till tomorrow, I got some reading to do. Talk to you then.